Hello guys, here we have some questions related to final exam of differential equations, so let's solve them together. In first question, we are asked to find the Laplace transform of this function. The Laplace transform of the last term has been given because it is a little bit complicated. The function is f of t equals 5 times e to the power of minus 6t plus sine 3t minus e to the power of 5t cosine 7t. We know that Laplace transform of e to the power of at is 1 over s minus a, and Laplace transform of sine at is a over s squared plus a squared. Laplace transform of the last term had been given. If the function is e to the power of at cosine bt, its Laplace transform will be s minus a over s minus a squared plus b squared. Now we can write the Laplace transform of given function. We can use both notation for Laplace transform. 5 is constant. 5 times Laplace transform of e to the power of minus 6t, that is 1 over s minus 6 plus Laplace transform of sine 3t, that is 3 over s squared plus 3 squared minus Laplace transform of last term, that is s minus 5 because a is 5 over s minus 5 squared plus b is 7 squared. Now let's simplify and finalize the answer. 5 over s plus 6 plus 3 over s squared plus 9 minus s minus 5 over s minus 5 squared plus 79. Now let's solve the second example. It includes two parts. In the first one, we have to write the following as a series that starts at n equals 6 instead of n equals 2. To start the series, to start at n equals 6, all we need to do is notice that this means we will increase the starting point by 4, and so all the other n's will need to decrease by 4. This series will start from 6, so we need plus 4. And everywhere else that we saw n, we will decrease that n by 4. N minus 4 squared times a sub n minus 4, we have another minus 1, times x minus 4 to the power of n minus 4. In the last steps, the final form of the series will be in the form that I'm writing. Now second part of second question. Write the following as a single series in terms of x minus x0 to the n. As it is clear, in this part there are two series and we are asked to combine them, and we are asked for only a single series. Therefore, we must subtract the two series at some point in time. We must always take care of any coefficient first, so we have 1 in front of the first series, so let's multiply it into the first series, and second series is still itself. We are asked to write this series in terms of x minus x0 to the power of n. So we need to apply some change to do it. In this question, as you can see, x0 is 3. The more important part of our work will be to get the two series prepared for the subtraction. It means that they will need to start at the same value of n and they will need the same exponent of the x minus x0. The exponent on the first series needs to go up by 2, so we'll shift the first series down by 2. On the second series, we'll need to shift up by 1 to get the exponent to move down by 1. So we could change the exponent. We increase the exponent by 2, so we need to subtract the starting point by 2. So the starting point or n is gonna be 1. Now we need to shift up by 1 to get the exponent to move down by 1. Now in order to subtract the two series, we need to get them to start at the same value of n. Depending on the series in the problem, we can do this in a variety of ways. Now please look at here. In this case, let's notice that since there is an n minus 1 in the second series, we can in fact start the second series at n equals 1 without changing its value, because if I put 1 instead of n in the second series, it will be 0, and I can say that it can't affect the series. It should be mentioned that in doing so, we will get both of the series to start at n equals 1, and so we can subtract. The final form of the answer will be as the following. Since x plus 3 to the power of n is the common in both of the series, so we can factor it out, have parentheses, and now we can write the series in this form, and it can be as a single series. The turn is for third questions. Let's solve it. We must find the solution to the second order differential equation of 3y second plus 2y prime minus 8y equals 0, given that these initial conditions. We know that when we have the second order differential equation, first of all we have to write the characteristics equation of that. The characteristics equation for this second order differential equation is 3r squared plus 2r minus 8 equals 0. Now, as it can be seen, this characteristic equation is quadratic equation, so we can solve it. I mean, we can find the roots of these kinds of equation using every method that you know, or in my opinion, the best method is delta. So I have used the delta method to find the roots of this equation. Delta is b squared minus 4ac, and we know that the coefficient of r squared is a, the coefficient of r is b, and the constant number is c. So let's find delta, and as I told, it doesn't matter, you can solve it using the methods that you know. The value of delta is 100, that is positive number. It means that we have two roots, two distinguished roots for this quadratic equation or for our characteristic equation. So let's find two roots, I mean r1 and r2. You know how to find r1 and r2 using this formula. We can find them, I mean minus b plus or minus radical delta over 2 times a. A is 3. After calculation, we could find that first root is 4 over 3 and second one is minus 2. When we have two distinct roots for characteristics equation, we have the general answer for this differential equation, that is c1 times e to the power of r1 t plus c2 times e to the power of r2 t, and r1 and r2 is the roots for that for that characteristics equations. Now let's substitute the amounts of the roots in the general answer. That will be c1 e to the power of 4 over 3t plus c2 e to the power of minus 2t, and we know that c1 and c2 are constant numbers and we can find them if we have initial condition. As you can see in this question, we have initial conditions, so we can find them. In the given initial conditions, as you can see, we have y prime 0 equals minus 20 as well. So we need to take the derivative of general solution to find the y prime of t, and then we can use that initial condition to find the constant numbers. Please look at the process that I'm doing to take the derivative of general solution. Let's plug in the initial condition in the general answer and in the derivative of general answer. So after that we can find the amount of c1 and c2 easily. Now, as it can be observed, we have a system of equations. I mean, we have two equations including two unknown variables. So we can solve them and we can find c1 and c2. Pay attention here, I'm solving, and you can learn the detail from this procedure. After solution, we could find c1 and c2. c1 is going to be minus 9 and c2 is positive 4. Therefore, the actual solution to the differential equation is in this form. The problem is solved. Let's solve the last question. In this question, we must find the solution to the Bernoulli differential equation of y prime equals 5y plus e to the power of minus 2x y to the power of minus 2, and there is an initial condition as well. In the first step, it is better to bring 5y from the right side to the left side. Look at right side. As you can see, there is y to the power of minus 2 in the right side. So we want to remove it. To remove y to the power of minus 2 from the right side, we multiply both sides by y squared. So equation is going to be y squared y prime minus 5 times y cubed equals e to the minus 2x. Now write down the substitution and then take its derivative. Now in this step we should look at the last equation and compare it with new parameter, so we can do some more procedure to find the first step. Now y squared times y prime is equal to v prime over 3. We can put it in the last equation. The last equation is going to be in this form which I am writing. Now we found that there is a 3 in denominator of v prime, so we can remove it by multiplying both sides by 3. Now we have a new differential equation. By paying attention to this equation, we can find that this is linear first order differential equation. And we know how to solve these kinds of equations. To solve these kinds of equations, we need integrating factors. Let's find it. The integrating factor is going to be e to the power of integral of negative 15 dx. Now we have to multiply both sides of this linear first order differential equation by this integrating factor. Based on our calculus knowledge, we know that therefore instead of left side we can write e to the power of negative 15x v prime equals 3 times e to the power of negative 17x. By integrating both sides, we will have now if we multiply both sides by e to the power of positive 15x, we can remove e to the power of negative 15x from left side. From the assumption, we know that v equals y cubed, so back substitute. In the final list, now we could find y cubed. Now we can use initial condition to find c. C was the constant number and we can find it using initial condition if it has been given. C was found and it is 3 over 17. Now we can write actual solution for the Bernoulli differential equation, but it is better to simplify and write y of t itself alone. problem is solved. Now don't forget to subscribe to your channel.